Alright, let's begin this demo of my graph search algorithm visualizer. First, I go into the README of the project, which describes how I can run it. I've already done all the steps except the last one, so I'll skip to the bottom and press run. This is going to take me to the graphical user interface, and the purpose of this app is essentially to create mazes for the computer to solve. On the left here is the grid on which search problems can be drawn. To begin with, the grid is empty, and to do a search we need to add an agent. There are 4 types of squares we can draw: agent, wall, goal, and empty. We can toggle them either by clicking or by pressing A, W, G, or E. I'll start by choosing the agent, and I'll draw one here. One thing to note is that we can only have a single agent on the grid at a time, so if I click on another square, it will remove the previous agent. Alright, let's now draw some goals and some walls. I'll press G to toggle the goals, and W to make some walls. And let's try to actually do a search. So currently the chosen search is the best first search, and it is described here below. The slider here allows us to adjust the speed of the search. Let's reduce it a bit to begin with, and then we press start to actually begin the search. The generated squares are gray, and the expanded squares are a color between red and green depending on the distance to the goal. Red means it's farther away, and green means it's closer. And it takes walls into account, so even though this goal appears close, the expanded color we see here is red. And note that sometimes the expanded squares are regenerated because their path cost is lower than when they were expanded. This makes the colored squares go gray. We can also see here in the bottom right that 67 nodes were generated to find a goal. Let's now try to make the grid bigger. We can make it any size between 2 and 40. I'll choose 30 and press enter, but I could have also pressed this apply button. This creates a grid with 30 rows and 30 columns. Let's now try to place an agent and a goal and try a different search algorithm. I'm going to try breadth first search because it creates a beautiful color gradient during the search. So let's try to run it. And of course now, since the grid is bigger, we should speed up the search a bit. Wow. All right. Let's now try to clear the search, but keep the goals and agent by pressing this button. If I also wanted to remove them, I could have pressed clear grid completely. And now I want to show another cool feature for the programmers. If we now go into the A* search, there is a custom heuristic function button. If we press it, a new window pops up. This allows us to actually choose the heuristic function for the A* algorithm used. Currently, it's set to the Manhattan distance, and we can see if I mess up the variable name here, the heuristic will not be changed, and it will just notify me that there was a syntax error. If I instead set it to a constant, like 1, and submit, we get successfully updated the heuristic, meaning that the A* algorithm will now use this constant heuristic. And since it's a uniform cost action problem, we will effectively see the same behavior as the breadth first search when we run it now. And that is the case indeed. And if I reset it by just going back or by manually setting it in the custom heuristic again, we will see that it is much more efficient now. All right, that's it for this demo. I hope you enjoyed it. Bye.